Today I'm going to show you how to draw a line graph. The results that I've got for this line graph today are from an investigation into the effect of light intensity on the rate of photosynthesis using an aquatic organism such as pondweed. So first off, you need to look at your results table. Whenever drawing out my results table, your independent variable will always go in the left-hand column and your dependent variable will go across the top with the mean at the end, so on the right-hand side. The way I remember this is, what do you need to buy alcohol? ID. So your independent variable will always go on the left-hand side first, so being the I, and then the dependent will always go in this column here. Now, my independent variable is the thing that I decided to change. And the way I remember that is that I am an independent person and I can change the things that happen in my life. So my independent thing in this investigation was the thing that I was able to change. And I changed the distance the lamp was from the plant. And I did 20, 40, 60 and 80. What depends on the distance? Well, how much the plant photosynthesized, and the way I was able to record that was the number of bubbles that the plant produced per minute. When completing this investigation, I repeated it 3 times, and each time I wrote down my results in this table. As you can see, because I've done it 3 times, I have a range of results, and I need to calculate my mean. I would add up 92, 90 and 80, divide it by how many I have. So 3. So now you can see I have a set of results that I will plot on my graph. So whenever I start a graph, I always do the same thing. I work out which way round I would like my graph to be. So portrait or landscape. By looking at my results, I can think about what is going to be easier to plot on a longer axis with more distance in between each number. And I think this one is going to be easier to plot. To find 87, so I always put on first my lines. I leave 10 little squares so that I have enough space to draw on my numbers and my axes labels. When looking at graph paper, some students get confused when you get this type of graph paper. You can't quite see the lines. If you look at this graph paper and find the lines on here, you can see that's one clear square. Now, on the next graph paper down, we can now see, if I zoom in, one little square is this size. However, the original square we drew is now this size. So they are the same size, but this one has 4 little squares inside. This then gets even smaller when you divide it up with the next graph paper up. And you can see the original square is here. The next square we drew is here, and then that has been divided up even further into one little square. So you can see that each large square has 10 little squares inside it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So sometimes teachers will ask you to draw your axis scale, and to help you work out, obviously use a ruler, to help you work out where to put each number when you're plotting it, it's easier to put lines on every 5 little squares. So if you were plotting something like the number 4, if you were plotting the number 4, you would put an X on the 4th square along. So 1, 2, 3, 4. And if you wanted to plot something like 7, you count from 5, so you know that 7's in between 5 and 10. 6, 7 is there, so I can put that on the line here. So my independent variable is going to go across the bottom, and that is distance in centimetres. So all I'm doing is looking straight at my table of results, and then up the side I'm going to write bubbles produced in 1 minute, but I'm going to plot the mean of my results. When you have so many results along here, you need to remember that these are going to be what you're plotting on a graph, not these ones. I don't need those 3 times either. The mean means we've taken into account the range of results and worked out the average, and that's what you plot on the graph. Mean number of bubbles produced in 1 minute, and now I can add on my numbers. So for the distance, I need to go up to 80, so I have to fit 80 on here, and as long as it takes up 1/3 of my axis scale, it will be the right size. So 10, 20, 30, 40, 50, 60, 70, 80. Oh, just slightly doesn't fit, so I'm going to make it smaller and do 20, 40, 60, 80, and that's taking up at least 1/3. Then, up here, what a lot of people do, younger students tend to write 87, 42, 23 and 9.7 on the side and just add their crosses. That's not how you do this. You need to make sure your scale is even and goes from the lowest to the highest. So my highest number here is 87. So I have to go up to, let's say, 90. So I could go 10, 20, 30, 40, 50, 60, 70, 80, 90. And then I can put on my results. So at 20 centimetres distance, my results say 87. So I have to go up to 87. So I can find 80, and then every tiny little square is 1, 5, 6, 7, and I can put on X. Now you can see the reason for putting the larger scale on the more complex numbers, as I'm able to clearly see 87 on here. If you are one little square out during the exam, you may not be given the mark, so I can clearly see 87. Next one, at 40 to 42. Then 60 at 23, and 80 at 9.7. Now you can see there is a very nice curve here, so I need to add on my line of best fit, and remember, a line of best fit is not always a line, it's confusing the name. So I can now draw on here a nice curve. Now I'm not going to scribble up and down, I'm going to put a very clear single line. Because I've done it slowly, I can add my nice curve, but also I haven't done dot to dot, which is what a lot of my students do. They will get a ruler and put on a line and go dot, dot, dot. That's not a clear, nice curve. And you can clearly see that as the distance increases, the mean number of bubbles produced goes down. So when analysing the graph, I can see the bigger the distance, the lower the mean number of bubbles. Bigger, lower. That's an statement.